Hello students and welcome to lecture 4 of the Systems 4 course. In this video, we shall talk about asynchronous programming using Python. You will be learning the following topics in this video: the concept of asynchronous programming and the key differences between synchronous programming and asynchronous programming. So what is asynchronous programming? Asynchronous programming is a model of programming that focuses on coordinating different tasks in an application. So basically its goal is to ensure that the application finishes executing those tasks in the smallest amount of time possible. From this perspective, asynchronous programming is about switching from one task to another when it is appropriate to create overlapping between waiting and processing time, and from there shorten the total time taken to finish the whole program. To understand the underlying idea of asynchronous programming, let's consider a quick real-life analogy. Imagine a scenario in which you are cooking a 3-course meal that contains the following: an appetizer that will take 2 minutes for preparation and 3 minutes of cooking or waiting time, a main course that will take 5 minutes of preparation and 10 minutes of cooking waiting time, and a dessert that will take 3 minutes of preparation and 5 minutes of cooking waiting. Now, consider the order in which the courses finish cooking, and your goal is to determine a way to produce the 3 courses that will take the least amount of time. For example, if we are cooking the courses in a sequential way, we will finish the appetizer first, which will take 5 minutes. Then we will move on to the main course, which will take 15 minutes. And then finally the dessert, which will take 8 minutes respectively. In total, the whole meal will take 28 minutes to finish. The key to finding a quicker way to go about this is to overlap the cooking waiting time of one course with the preparation time of another. Since you will not be occupied while waiting for the food that has already been prepared for cooking, this time could be saved by preparing the food for another dish. For example, improvements could be achieved through the following steps: preparing the appetizer 2 minutes, preparing the main course while waiting for the appetizer to cook 5 minutes. The appetizer will have finished during this time. Preparing and cooking the dessert while waiting for the main course to cook, that is 8 minutes. The dessert will have finished during this step and the main course will have 2 minutes of cooking remaining. Waiting for the main course to finish cooking, 2 minutes. The main course will have cooking finished during this step. By overlapping the time, we have saved a significant amount of time cooking the 3 meals, which now takes only 17 minutes in total compared to 28 minutes if we had done this in a sequential way. However, there is obviously more than one way to decide which dish we should start first and which dish should be cooked second and last. Another variation of cooking order could be as follows: preparing the main course, 5 minutes. Preparing the appetizer while waiting for the main course to cook, 2 minutes. The main course will have 8 minutes of cooking left. Preparing the dessert while waiting for the appetizer and the main course to cook, 3 minutes. The appetizer will have finished during this step and the main course will have 5 minutes of cooking left. Waiting for the main course and the dessert to finish cooking, 5 minutes. Both the main course and the dessert will have finished during this step. This time, it takes only 15 minutes in total to produce the whole meal. As we can see, different variations of the cooking order might result in a different total cooking time. Finding the best order to execute and switch between tasks is the main idea behind asynchronous programming. Instead of executing all the instructions of that program in a sequential way, we coordinate those instructions so that we can create overlapped waiting and processing times, and finally achieve a better execution time. Here we talk about the difference between synchronous and asynchronous HTTP requests. This is just an example to explain the difference between asynchronous and synchronous programming. Asynchronous programming is one of the major concepts in concurrency, specifically, and in programming in general. However, it is quite a complex concept that can be considerably challenging for us to sometimes differentiate it from the other programming models. So we can say that asynchronous programming is fundamentally different from synchronous programming because of its task switching nature. As you can see in the figure, in synchronous programming, the client is making a request which is given to the server. Now, when the server is executing that request, the client is waiting for that response. And the client will resume its execution only when it receives the response from the server. But as opposed to asynchronous programming, the client makes a request and continues its execution, and then when it gets a response from the server, it will do something. So this is basically the difference between synchronous and asynchronous. I'll explain this in detail. So one common example of asynchronous programming is the interaction between a server and a client during an HTTP request. If HTTP requests were synchronous, clients would have to wait after making a request until receiving the response from the server. Imagine a scenario in which your browser would hang every time you go to a new link or start playing a video until the actual data returns from the server. This would extremely be inconvenient and inefficient for HTTP communication. So, in synchronous programming, the instructions of the program are executed sequentially. A task has to have finished executing before the next task in the program starts processing. With asynchronous programming, if the current task takes significant time to finish, you have the option to specify a time during the task at which the execution is switched to another task. As we have observed, doing this would result in potential improvements in the execution time of the whole program. A better approach is asynchronous communication, where the client is free to continue working, and when data from the requests made returns from the server, when the client then will be notified and it will proceed to process that data. Asynchronous programming is very common in web development and in general communication, network communications, software data processing, interactions with databases, and all of these applications take the advantage of asynchronous programming. Contrary to synchronous programming, asynchronous programming provides responsiveness for users by preventing the program from hanging while waiting for data. Therefore, it's a great tool to implement in programs that deal with large amount of data. Finally, we define what is a coroutine. So coroutine in simple terms is just a function which can be paused and resumed during its execution. Look at a scenario here. We have three functions A, B and C. Or we'll rather call them as coroutines, because Python calls functions as coroutines if it is using asynchronous programming. So we have three coroutines A, B and C. When coroutine A starts its execution, it stops. It has been preempted, or it stops its execution, and then coroutine B starts its execution. After B executes for a small amount of time, it has been stopped or it is paused, and coroutine C starts its execution, and so on. So every time there is a preemption, or the coroutines are preempted rather, and they are paused, and then they resume their execution after some time. So in this way, you can see that all the coroutines A, B, and C are executing in a concurrent manner. So the problem is how to define a coroutine. So in Python, there is a keyword which is called as async. And this keyword async means that this function main or this coroutine named as main becomes a coroutine. If you do not write the async keyword, then it's a normal function. So async is the keyword that we use, and as soon as you use the keyword async, it becomes a coroutine. So once you have defined what is a coroutine, there's another question that we need to ask, that is how to pause a coroutine. Because I don't want any function to run indefinitely. Or maybe I want to run a particular function for some small amount of time and switch to the other function. So how do you pause the execution of the coroutine? So when you define the coroutine as async def main, then you have to use the keyword called as await followed by awaitable object. So this await keyword helps you to pause the execution of the coroutine. And what are awaitable objects? Awaitable objects could be coroutines, tasks, and futures. So tasks are used generally to schedule the coroutines concurrently. So tasks are the fundamental objects in the async.io library. So if you see here, we have used a library called as async.io, which is an inbuilt Python library, and this library has to be imported into your concurrent program in Python. So there is an inbuilt Python library available to write concurrent programs in Python. So this tasks are then used to schedule the coroutines concurrently. When a coroutine is wrapped into a task with functions like async.io.createTask, the coroutine is automatically scheduled to run. So what happens with this function called as createTask is we are converting the coroutine into a task and scheduling it for execution. And finally, we have a future. A future is a special low-level awaitable object that represents an eventual result of an asynchronous operation. So future is basically a base class of some higher level classes in async.io. So this is what is async.io. It's a Python library, and it is basically used to write concurrent, asynchronous, and cooperative code in a sequential style. So we've been learning and going through the meaning of the word concurrent. So concurrent is basically doing multiple things at once, versus parallelism is doing multiple things at once. So we are going to talk about what is concurrency and what is parallelism here, just to understand the definition of async.io. So concurrency is we start many tasks at a time. You can start many tasks and they can complete in overlapping time periods. So you can switch between, now suppose you have a task, a yellow task and a red task. So you can switch between a yellow task and a red task as and when the user wants. So the control lies in the hands of the user or the programmer, the person who's writing the program. So depending on that time span, he can switch between these two tasks. And the duration could be, you can see that the duration here is not fixed. So it is in the control of the user. Whereas when you talk about parallelism, in parallelism what happens is the tasks are running parallelly or simultaneously, and there is no preemption. So each independent task is executing on its own. So there is no interruption here. That is what is the meaning of this word called as concurrent. Now we talk about what is asynchronous. Now in asynchronous, now if you look at the image here, and these are the tasks. This is a blue task which is being performed, and this green task is parallelly running here. And this blue task continues its execution. It is not stopped or paused. In asynchronous execution, what happens is The blue task is continuing its execution and the green task is running parallelly here. So there's no need to wait before proceeding, and therefore the overall duration of the program execution is obviously going to shorten. Whereas in synchronous or sequential programming, you can see that the blue task is preempted at this point and then the green task is executed, and only after the green task is completed, the blue task resumes its execution, and hence resulting in an overall longer duration. So this is the meaning of the term asynchronous. So here we are going to talk about asynchronous, because in asynchronous programming we can achieve concurrency. And finally we talk about cooperative. What is cooperative versus preemptive? Now in preemptive multitasking, there is a program called as a scheduler, and this scheduler is responsible for interrupting the tasks. Now for example, you have a red task, you have a yellow task, and you have a green task. So all these tasks are given some fixed amount of time to execute, and after that time period finishes, it is preempted, it is stopped. Preempted is, it is stopping, it is paused. And then the control, or there's a switch. There's a switch, context switch between red task to the yellow task, and then again there's a context switch between yellow to green task, and so on. So these context switches are inconvenient. They're very inconvenient in programming languages. As opposed to cooperative multitasking, there's nothing called as a scheduler here. In case of preemptive multitasking, we have a scheduler because the scheduler is responsible for giving priority to the task and executing them for a certain amount of time. And this execution is not in the control of the user. The scheduler is handling all this. Whereas in cooperative multitasking, the tasks yield to scheduler. So there's no scheduler here. Here, suppose there is this is a red task that has to be executed. It can be executed for 5 minutes, 10 minutes, and this will depend on the programmer or the user who is writing the program. So the execution of the programs or the tasks in cooperative multitasking lies in the control of the user. The user can control the execution, and so it is called as cooperative multitasking. So going back to the definition of what is async IO, here we can see that async IO is to write concurrent, asynchronous and cooperative code in a sequential style. So these three words or these three terminologies are important in this context. So that is why this async IO library is very fruitful, and it is very useful to write concurrent programming. Yes. So now we talk about the applications of async IO library. Async IO is used as a foundation for multiple Python asynchronous frameworks that provide high performance networking and web servers, database, connection libraries, distributed task queues, and so on. So it's used in many application areas, and it's a wonderful library with a lot of built-in features. And then finally we talk about, so now we have defined a coroutine, we have seen how to pause a coroutine, and now we have to see how we execute a coroutine. So this is also an important feature here, how to execute a coroutine. So this coroutine is executed with the help of an event loop. So what is an event loop? So this event loop is the core of every async IO application, and it runs in a thread. Thread means it runs in the main program or the main function that we write, and executes all callbacks and tasks in its thread. So these are the three lines of code that we need to write when we have to execute a coroutine. So loop is equal to async IO dot get event loop. So these are all inbuilt functions in async IO library. Loop dot run until complete, and you have to specify the coroutine that you have written in your program, and loop dot close, which will end the event loop. So if you are using 3.7 and less than that, like if you are using 3.6 version and less than that, then you have to write these three lines of code for using an event loop or to execute a coroutine. And for 3.7 onwards, you can just replace these three lines with this one line of code. So if you have a Python version of 3.7 and above that, then async io.run and specify the coroutine here. So this helps you to execute the coroutine. So in no time we shall write some code in Python so that you understand how async IO and is defined, how you're defining a coroutine, how you're pausing it, and how you execute the coroutine. And then there is one more thing that we need to know: how do you block a coroutine? So to block a coroutine for some seconds, or for some x seconds, so you have to use a function which is called as async io.sleep. So if you define this main function as async, so it's a coroutine and you're printing something, then you say await async io.sleep, and you're making that this coroutine main sleep for 3 seconds, and then again it returns to this particular function. So async io.sleep always suspends the current task, allowing other tasks to run. And then how to execute the coroutines concurrently. So you need to use a function called as async io.gather. So when you use a function called as async io.gather, and then you define this as async def main, this is a function definition, await async io.gather, and in this you give all the coroutines that you have defined: coroutine 1, coroutine 2, coroutine 3, and so on. And async io.run main, so this is just one line of code for event loop. So this is for Python 3.7 onwards. So let's see how we can write some code for doing this. Now I'll just execute this in Jupyter Notebook so that you can immediately see the output of whatever code that we are writing. So here, if you just define a function called as main and you print something, suppose you print happy, okay, and if you execute this, now I'll just run this code and I'll call this. So if I call this main function, and you see that you get the output as happy. Now the moment I define this function as async followed by def main, okay, this will turn into a coroutine, and I say print happy. So this is just a small line of code. I'll just execute this and you call the main function, and now just look at the output that it gives. Now it is returning this main as a coroutine, and the output that you get after executing this coroutine is it's a coroutine object, and it has got some location. Now how to execute this coroutine object and how to actually get the final output, we'll do it in the next video. But now you just understand the difference between what is a normal function or a normal function that we write in Python and a coroutine. So this is basically the difference. So just adding the keyword async will make the function as a coroutine function. Okay. Now I'll just take you to the another program of Python so that we understand how async IO is used basically to do concurrent programming. So here I'll just import async IO. So I'm importing async IO. I'll define a function as async def main. I'll write a simple coroutine which will make you understand how exactly this is used. So print, and here I'll just say print, okay, and then finally I'll just write the loop event. So I've written a coroutine called as main. I've imported the library async IO, written a coroutine called as main, and I'm printing something. That's it. Now I'll execute the event loop. I'll say loop equal to async IO dot get event loop. So this is basically a built-in function. And then loop dot run, it gives you the function run until complete, and you have to give the coroutine here, specify the coroutine. And finally loop dot close, because you need to close whatever you have opened. So if you execute this function, I'll just try to run this program. So you see, now the event loop is already running and it is printing the word happy. So since I have only one function that has to be executed. So this is a simple coroutine that was written just to print some message here. Now, how to pause an event and how do I make the process to sleep for a certain amount of time. So after print, suppose I write this as await, because for pausing the function or for pausing the coroutine, we use a keyword called as await async.io dot sleep, and I'll make it sleep for 2 seconds. And then after it is done, I will print another message, happy learning. Now when you execute this code, you can see that after executing this code, it will print this portion first, it will print the word happy first. It will pause for some amount of time because we are making it sleep for some amount of time, and after sleeping it will print the word learning. You can just observe this output there. So after happy is printed, it will wait for some 2 seconds because we have made it sleep for 2 seconds, and then it will execute the word, then it will display the word learning. So this is how we have used async.io for defining the coroutines. So here, this was just small amount of code that we had written. So the task that you have to do based on whatever we have done in this video is to write a concurrent program, a concurrent Python program to display whether a number is prime using async.io library. So you should consider very large prime numbers. I'm not talking about very small numbers. I'm talking about huge numbers such as which are displayed here, n1, n2, n3. So such large numbers. And you have to submit your observations on Moodle assignment to one link. And your answer should include the time required for the program to display the output with and without using async.io. So basically you need to write 2 programs to display whether a number is prime or no. And you have to take these examples displayed on the slide, and you have to note the time required for the program to give the output for n1, for n2 and n3 without using async.io. Means I want you to write a sequential program, a simple program, Python program for finding whether a number is prime or no, and then converting that program to a concurrent program using async.io and find the time. And once you write these programs, you will identify the difference between the 2 programs. So, and you have to answer the question, could you achieve concurrency and increase the performance of the program? So, when I'm talking about increasing the performances, I'm talking about the time that is required to display the output. And this task needs to be submitted on Moodle by 5th of September. So, that's all for now and in this video, and thank you so much for watching.